Alright, so it's time to take a look at the other inverse trig functions, since last time we only focused on sine and cosine. Now we have to take care of the inverse tangent, cotangent, secant, and cosecant. So what we're going to do is quickly just look at the graphs of the inverse of tangent and the inverse of cotangent, but I'm only going to show you the portion that gives us our principal values. You can imagine how this part of the graph would just keep repeating itself with all these asymptotes going up and down the y-axis there. So if we limit ourselves from negative pi over 2 to positive pi over 2, that gives us a function for the inverse of tangent. So that means that our range for the inverse or arctangent, the principal values, is going to be from negative pi over 2 to positive pi over 2. But notice there's no equal sign with our inequalities. And that's because there's these asymptotes at both of those values. And the asymptotes mean that at that particular value, tangent's going to be undefined. So we can't actually have those as potential answers. Okay, so let's do the same analysis with arc cotangent. This is what its graph would look like. And if we just take this one region here between 0 and pi, between these two asymptotes, we would get our principal values. So that range is from 0 to pi. Once again, not including the asymptotes, those values, because they would be undefined. Okay, so these ranges that I have here, these should look familiar because they're very similar to what we had for sine and cosine. And if you recall, with our All Students Take Calculus, for sine, we were using these two quadrants, right? And then for cosine, we were using those two quadrants. Which, if you remember, this was, A is always for positive, and then this would be the negative quadrant for sine. Here's A is positive, and then this is the negative quadrant for cosine. So it follows the same rules as the quadrants for sine and cosine. And the way you can remember that is that tangent, the definition of tangent is sine over cosine. So the numerator is sine. So we're going to use the same for sine. Over here, cotangent is cosine over sine. So we're going to use the same quadrants for cosine, which is in the numerator. Okay, so there's tangent and cotangent inverses. Let's take a look at secant and cosecant. All right, actually we'll do cosecant first. So arc cosecant, I know this looks really weird. Here is one asymptote that we have going through the graph, and you can kind of imagine, you know, this right here. If I continued on, it would be that other half of the branch that kind of looks like a parabola, right? And then there would be another asymptote here, another asymptote up there. But when we do that, we end up failing the vertical line test because now this is not a function. Okay, so by limiting our values to go from negative pi over 2 to positive pi over 2, we've now created a function. So those are our principal values. Interestingly enough, now we get to use negative pi over 2, positive pi over 2, but we have to eliminate the value of y equals 0. And that's because there's our asymptote right in the middle. It'll be undefined at that value. Okay, so doing the same thing for arcsecant. Here's my asymptote directly in the middle at pi over 2. I'm going to go from 0 all the way up to pi. Once again, you can imagine the rest of the curve here and up there. So if we look at this, here's our principal value range from 0 to pi. And we exclude pi over 2 as a possible solution. So just like with the tangent and cotangent inverses, the principal values, they follow the same rules as sine and cosine. So just like before, cosecant is the reciprocal of sine, so we're going to use the two quadrants associated with sine. And secant is the reciprocal of cosine, so we're going to use the two quadrants associated with cosine. Okay, so really this is nice because there's nothing new, no different rules for quadrants from before. We just have to remember which one is associated with sine and which one is associated with cosine. So let's look at some problems. Okay, so the first question asks us to evaluate arcsecant of -2. So the first order of business is to figure out what quadrant is this going to be in. So ask yourself, secant is the reciprocal of which trig function? And hopefully you're saying cosine. And then you say, well, which quadrant is cosine negative in? And that should be quadrant 2, right, since we can't use quadrant 3. And so if we place it over here in quadrant 2, knowing that secant is a reciprocal cosine, so this is -2/1, so -1/2, we can place those values. We know that this is √3, or if you have your unit circle, you could just look at your unit circle. But to figure out what this angle is right here in quadrant 2, it should be 2π/3. Okay, so that's not too bad, but then we jump over here to number 2, and this is where it gets a little complicated, because look, there's a 2 right here. You gotta ask yourself, what is that 2 doing there? Well, remember that this whole thing right here, arctangent of -8/15, represents theta. That's an angle. When you evaluate the arc sine, arc cosine, arc tangent, arc cotangent, anything arc, you're getting an angle. Just like over here, we got an angle when we evaluated arcsecant of a fraction. So this is some angle theta that we don't know. So what that means, this 2 is being multiplied by theta. So really, they're asking us to evaluate the sine of 2 theta. Oh dear. Now we need to go back and remember our double angle identities from before. Okay, so to do this, we're not actually going to figure out what the angle theta measures, but we're going to use this information to create a triangle that we can reference to figure out the sine and cosine of theta. So arctangent is negative. So which quadrant will it be in if tangent is negative? So remember, tangent follows the rules of sine, and sine is negative in the 4th quadrant. So we can draw this triangle in, plugging in the -8 and the 15 for opposite and adjacent. Remember, the negative goes with the 8. Calculate the 17. And now we're going to use this triangle for theta in order to evaluate the sine of 2 theta. So hopefully you remember your identity. Sine 2 theta is 2 sine theta cosine theta. So now we just have to plug in what the sine of theta is and what the cosine of theta is. So if you look at your triangle, the sine of theta is -8/17, and the cosine of theta is 15/17. So we plug that in, multiply it all out, and we get our answer of -240/289. And that's it. Okay, so good luck, folks. Hopefully this won't be as bad as the first time you did these, since you're getting a second exposure to it. All right, talk to you later.